Hi, welcome to our first lesson of the Continuous Integration Workflow course. Before we can dig into code and tools, we need to know what continuous integration and continuous delivery is. That will be the agenda for this lesson. Continuous integration emerged from a development concept called extreme programming in the 90s. It advocated integrating several times a day, something that wasn't common in the old days. If there even was an automated build system, there were only nightly builds, which means a server running a build once per day at 2 a.m. And when you came into the office the next morning, you'd see if the build succeeded or not. Then the bug fixing began. Nowadays, every push to a repository normally triggers a build on the server, with 100 or more integrations every day. Now back to the concept of continuous integration. When working on a shared code base, everyone is creating a different feature, and sometimes the implementations of those features don't play well together. This can happen due to different approaches to tackle a problem which is shared between multiple features, or even a small thing like the different naming of a method or class. Continuous integration aims to prevent this so-called integration hell by using a build server and automated tests to test tiny changes to the code, single commits or pushes to the repository, even when the feature isn't yet completed. To be able to also test the feature against the current master branch, which might have gone forward after starting, developers should regularly merge master into their development branch to ensure compatibility before the feature is fully completed, and to be able to adapt in small steps. Since the build server takes care of testing, developers don't have to manually verify everything works if the code base is well covered with tests. Continuous delivery extends continuous integration by not only running automated tests, it also takes care so that the software is in a state that is deployable to the user at any time. In case of a software product or a mobile application, this would mean that after all tests pass, the software will be compiled, installers will be created, and other assets will be prepared. In case of a web application, this can go so far that the software will be deployed to the servers automatically, for instance, either to a designated test environment or directly onto the production servers, running necessary migrations and compiling static assets like style sheets or JavaScript. Such a delivery process is called a deployment pipeline. Normally you have multiple of those. Using the example from before, you could have a pipeline where the master branch gets deployed to a test environment, and another one where a production branch, after QA merges the changes from testing, gets deployed to the production environment, and different other services get triggered or will be notified about this deployment. Some companies like GitHub have a delivery process that allows them to deploy a feature to a single server in their production environment to ensure the rollout won't cause any issues. This isn't completely automatic. It has to be triggered by a developer, but the build server will run the tests before, and a deployment pipeline tailored to this approach will be used. As you can see, continuous integration and continuous delivery especially can be very different depending on your very special use case. But this isn't always the case. With the introduction and broad use of web frameworks, the delivery process is similar every time. Companies like Travis CI and CodeShip use this fact to provide a simple interface to the not-so-simple configuration of build servers. That is all for this lesson. I'll see you in the next one, where we are going to talk about the two development approaches, Git Flow and GitHub Flow. See you there!